Okay, so let's go back. Okay, so we see this semester for this class, we just discussed this apply stats 1. So we just discussed some basic stats questions. So stats question just one sample, two sample, many sample. Man, okay. Okay, and also so those are one sample, two samples, many sample, just only one variable. Then we have like this one regulation. So this regulation we can say one sample. We say this one sample. But many variables, right? So those one sample problem, two sample problem, those we can say those just the one variable. Okay. Okay. So those are typical stats problems. Okay. So we say in order to start statistics, in order to make statistical conclusion, we need to tell other people like what the chance our conclusion is true. So this percentage chance, this chance is just a probability. So at the first we have to discuss some probability issue. So for probability, we have simple probability and conditional probability. Right? We have simple probability or conditional probability. So those conditional probability is just check this part, typical part. So for probability, let's say usually probability is just for all we split into parts, right? So if we consider probability for all, this is just the simple probability. So simple probability, typical simple probability problem is just take some from this group or from all. So what is the chance? What is the chance that those you picked are from this part, right? Or from that part. So if we just consider the chance for this part, a typical part, we just check this part. So those are just a conditional probability, right? Okay, so then connect the probability and statistics is essentially limit theorem or sampling distribution or just x bar follow this, x bar follow this normal. Okay. Okay, so we say those are topics we have covered for this class. So if we just go back to the course material, it's very easy, very simple, just those things, right? Some probability or simple probability, conditional probability, and for stats, we have those typical stats question, one sample problem, two sample problem, many sample problems. If those many sample problem based on categorical data, so this is a one-way table, two-way table. Right? If the data, the numerical data, like based on we compare 3 classes based on our final exam, then this is a ANOVA, right? Because the data numerical data. Okay. And if we just check one class, one sample, but many variables, then we have we will check. If we have many variables, usually we will check their relationship. We cannot compare which one is bad, which one is big. I'm sorry. So it depends. Sometimes we can compare, suppose in our class we have exam 1, exam 2, and final. We also can compare whether your performance for final exam and exam 1. So this is just two sample problem, right? If we just compare all exams, exam 1, exam 2, and final, so this is a many sample ANOVA problem, right? Yeah. Okay. So so just from data we just can produce those typical static questions. Static question just like how many number of sample, or how many variables, or one variable, or two variable, or many variables, or the data is categorical, or the variables based on a categorical variable or a numerical variable. Like for our grades, this is categorical, right? For our exam score, this is numerical. And numerical and categorical we can exchange, like from your total percentage. So it's numerical value. Your total percentage 92.1. I just convert this as grade A, right? So we can change this from numerical to categorical. So sometimes categorical also can change to numerical. Like typically, like your GPA is just if your grade is A, I give you 4 points. If your grade is B, I give you 3 points, right? So this is just the exchange from numerical data to categorical data. Okay. Okay. So now let's check some sample problems. So first one is simple probability. So this is really easy one, like from our class pick some, pick 5. Saying this 5 from where? So what the chance this 5 come from this part, or what the chance this 5 are all from female? So we use this, right? So I hope that you, after taking this class, you should understand those notation, right? So from 25, I just pick 5 people randomly. So we have so many ways. And for female, if I guarantee all are female, then I can only from female from this part pick 5, right? So if we change this, we have 3 male or 2 female, or this is also easy, right? So from this part pick 3, from this part pick 2. So those are typical. This is simple probability problem, right? Okay. So if we pick many, we use this notation, right? If we just pick 1 or pick 2, maybe we don't need this notation. Like from our class pick 1, from this pocket, or from this play cards pick 1 card. What the chance you got an ace, or you can get a heart? Those are really easy, right? Okay. So then we have conditional probabilities, or we have this notation. We say, what is this probability? P, probability for getting A from male students. So then, so here we say male students, we just focus on male students. So totally we have 16 male students. Then, among them, how many get A, right? Okay, so for this one, like we say that from a student, how many are male? So a student, so we have only 6, right? Got A, so among 6, we have 3 are male, right? So for this one, so this is the no conditions, meaning we need to check all. So here we find the denominator 25, right? Check all. So from all, what is the chance those people meet those requirements? A greater is A and male. Okay. So we also, so this notation and. So we also can have those problems like probability for A or A. So here total is also 25. So you need to find among all how many certifies as either greater is A or male. Okay. Okay. So then this one is so this one is let's say find what is the probability that the average GPA in our class. So this is X bar, right? Our class average or X bar our class average between this. So we need to know X bar's distribution. So these things. This is important. X bar follows this. This is with the foundation for stats. X bar follows us. So you plug in here. X bar the mu equals mu is mean for all. So we assume 2.8 and sigma over n. So if X bar follows this normal, so then find this probability. So such a problem is also easy, right? From normal distribution, we just want to find the related probability. So we can find what the probability for our class average is larger than this or less than this or between these two numbers. So we can have those kind of problems, right? Okay, so those one I think should be easy to everyone. Those are just routine problem. Okay, and then we have find a confidence interval. So this is just like estimation. So from our class information, we wanted to estimate population information. So here we use the formula. If we find a confidence interval, so we use the formula X bar plus or minus Z star or T star. Then so here we have the formula like X bar plus or minus Z star. So here's sigma or X bar plus minus T star. So S over radical A. So we have two formulas. Then you should correctly determine which formula to use, right? So this depends on sigma or S. So sigma or S, this can be a little bit confusing. Yeah. Okay. So let's say, so how can we determine which formula to use? So we say this one we do not have formula. We do not have some typical rule. We just say use, understand, check the problem itself. So it says from our class, we find the average GPA is this with standard deviation that. So this standard deviation we find from. From our class, we find this and that. So this standard deviations just come from our class, right? So this is S. Okay, so S we should use this. So you need to find a T star. So find a T star is a key point. So T star. So you should check degree of freedom. and confidence interval. So based on this confidence level, you can find the T star. So we have such a problem, like I just ask you to find a T star, right? So please just check this, whether my T star is correct or not, and you can find check why and where this number, this T star come from. Okay. So here this one, can we believe something, or some people say something, can we believe this? So such a problem usually is a testing problem. Can we believe other people? Other people say something, can we believe? So there's a testing problem. So testing problem, let's say, can we believe the average for all students? So average GPA for all students, this is mu, right? Mu, so this means mu can be at least this. Can we believe mu is at least? So that means larger than, right? Can we believe this? Okay. So here we say maybe we cannot believe this. Okay, so we put mu HA as less than. So here larger than. So which HA should be? This is depend on us. So here usually we say what good or not good meaning. So here we're talking about a GPA. So we say GPA is high is good. So not good means less than 2.8, right? So then find the test statistic. So there's a t value or z value. So also we need to check this standard deviation is from this from our class. So this is not sigma. So there's a t value, right? So find there's a t value. So we say this is p value. So we need to check a p value larger than or less than 0.005. Okay. So to make decisions, check p value. Also, we can determine like this is big or small, or quite far away from 0 or not, or close to 0. We just need to determine this big or small. So we find critical value. So critical value for 0.005, so one tail. So this is one tail. So we find the critical value here. This is 0.005. This critical value is 1.77. Okay, so this is here. The critical value is here negative 1.77. Right? This critical value is here. So we find 1.25 is close to 0. Close to 0. So we can believe this. Okay. Believe the equilibrium. Okay. Okay. Okay, so for this one, very clear, this is a two sample problem. So we want to check they are equal, no difference, or have a difference, or this class 1 is better than class 2. So we use this, right? So find the test statistic. So use this formula. Okay. And then determine this big or small. So we find the critical value. Yeah. So based on this critical value, we say this big. So this big means difference is significant. And we can say class section 1 is better than section 2, right? Okay. So for this one, we compare the proportion for male and female. Different people, or male or female, have a difference. So we find for males percentage thus, female percentage thus. Use numeric numbers. So we say these percentages are close, or not so close, or differ very much. So to this problem, so we find this test statistic. So test statistic, just use the same formula like x bar minus y bar over, we just use this, right? S1 square over n1 plus s2 square over n2. Okay, so go back to here, becomes this, right? So s1 square is p1, q1, p1 hat, q1 hat. Okay, so this test statistic, we call this z value. So logically, this should be t value. But we say when sample size is quite big, z value, t value, no much difference. So we just simply use z table z value. So do some calculation, find this number thus. So then we just determine this is close to 0 or not so close to 0, right? So here's 0, here is negative 2.84. So close or not so close. So we need to find critical value or find p value. So p value, so here we need to multiply 2. So why we need to multiply? So this is like why we need to multiply by 2. So this is one tail or two tail. So here this depends on the question. So the question is, we just check male or female different or not. They have some difference or no difference. We do not mention male is higher than female, right? We just check whether male and female have different opinion. So here we say their HA is they are same or not the same. So not the same means two side or two tail. So there's a two tail. Okay, so we need to multiply by 2. Okay, so you also can check critical value. So critical value for, so there's a critical value for two tail, and alpha is 0.05. So you also can check this critical values. Two tail is this, right? So check this. Okay, so this is standard normal, and here's 0. Okay, so two tails is the cutoff point such that all the sides is 0.05. Okay, so this cutoff point, I think, I don't remember. Let's see. All the sides is 5. So this is just 95%. Yeah. So this is just 1.96. Okay, here we say negative 1.96. So we say critical value. So this is critical value. So this critical value, we also can call this z critical value equal negative 1.96. So we just use this to determine. So we see like here negative 1.96. So we use this to determine, or we can say those numbers close to 0. But outside, so negative 2.84 is not close to 0. It's far away from 0. So we also can say that those difference very significant of male or female. Their opinions differ very much. Okay. Okay, so now for this one, this is just compare two sample. Yeah, compare two sample. So we did this before, but here we say under the assumption of equal values. We under this assumption we compare two samples. So for test statistic we have two formulas. One is t-value is x bar minus y bar over s1 square over n1 plus s2 square over n2, right? So the other one is thus x bar minus y bar. So here, if we assume values equal, so we can take these values on the side. So this is equal 1 over n1 plus 1 over n2. So we should use different formula. So okay, so t equals this. So okay, so which formula to use? So if we assume the values are equal, then we should use this one. So here use this one. So here x bar 85 minus y bar 81. So SP we need to find 1 over 36 plus 1 over 25, right? So here, how can we find SP? And we call this SP as pooled standard deviation. So find this SP, we need to find SP square. So SP square is called pooled variance. So this pooled variance, we are put to here, variance. We say is the weighted average for those variance. So here we have variance 6.8 square and 4.3 square. So those are variance, right? So weighted average for them. So weighted on what? On the degree of freedom. So there's 6.8 degree of freedom, 35, right? N minus 1, 35. And this degree of freedom, 24. Okay, so then over total degree of freedom, I think 59, right? 59. So use this to find pooled variance. Okay, so find then just so check this big number, small number, then make a decision. Okay, so this is just we already discussed this, right? Okay, so now if you compare four brands of paint, compare four, so data like that, compare four. So this is we should use ANOVA. Right? So for each one, we should take 6 samples, like this. Okay, so we use ANOVA. So here, I just tell you 2 of them. So this number, we say this S is paint, or S is G, and S is total. So you can find S is E, so this minus this, right? And then find the degree of freedom. So there's a degree of freedom. So here is 3, right? We compare 4 groups. Then degree of freedom is in K minus 1, 3. Then what is total degree of freedom? The total degree of freedom is n minus 1. So what is N? So N is, we have 4, so each one 6, 4 times 6, right? So 24, total N equal 24. So this equal 23. Okay, so then total degree of freedom 23, then there's 20, right? Okay, so then we can find, so MS here, MS means MSG, so this number MSG, MSE, this number MSG, MSE, then we can have F value. So F value equal like MSG. So here the M is pent G over MSE. So this is F value. So here M stand for mean or divided by degree of freedom. So MSG is just C is divided by degree of freedom. S is divided by degree of freedom. Okay, so we can find F value, or we can fill out this. We say such a table as a NOVA table. So computer output usually give us such a table. There's a table we call a NOVA table. Okay. So for a NOVA table, the most important number is F value. Yeah. So from F value, we want to determine, we want to make our conclusion. So we want to determine this F value is big number or small number. So how can we determine big or small? We check F table, find the F critical value, right? So if this F value is big, so what we can say? F value is big, meaning MSG or SSG is big. From group to group, so have a difference, right? Okay. So here we say, suppose like we find F values as, I then determine this big number, small number, so we use F critical value. So F critical value is as, so we can say this big number. So this is big. So we can make our conclusion. So determine big or small. Also, this means p-value is less than 0.005. So from p-value, we say that if p-value with a small HA, so HA is have a difference, right? And we also can, based on the F value, we can determine, we can make the same conclusion. If this F value is big, so this means group to group, their difference is big. Okay. Okay. So then this is one. So for if data small, I will ask you to find SSG, SSE, those things, SST. Okay. So here you should understand how can now SAT is this. You should not forget. You suppose SAT equal data minus each data minus the average square. Add them up, right? So what is SSG? SSG just those SST was the data replaced by group mean. So group mean, so means like everyone in that group no difference. So just everyone same number. Okay, so I repeat this simple example again. I suppose data like that. So how find SSG? SSG means like in this direction. No change. So only the data looks like 222, 555, 88. So suppose data like that. What is SST? Right, so this SST is just SSG. Okay. So suppose the data like we say based on similar data. Like this, we have 4 classes. So I will find SSG or SSE. Okay, and F value and make a decision. So just remember what is SSG. SSG just like that. Like in class 1, everyone is 84, right? Like this. So in this direction, no change. So class 2, everyone is 81, 81, right? 81, 81, 81. So like that. So for such data, how can find SST? So SST is equal each number 84 minus total average square. So we have how many? 84, 84, 84. We have 25, 84. Then plus like that. 81, 81 minus x bar. So this x bar is, and how many is those 81, 81, 81? We have 20, right? Okay. So what is x bar here? X bar is just the data like we can say x bar is just the average for there's 4 classes. So you need to find this x bar for 4 classes. Okay. And once we have this, find f value. So really easy, right? F value is SSG over degree of freedom. So degree of freedom here, if we compare 4 classes, this is 3, right? So SSE divided by this degree of freedom is also easy, right? So we just check total N. Total N is put 4 classes together. So this one I think is 88, right? Okay. So total degree of freedom is 87, and then this is 84. Okay. So once you find f value, make a decision, just determine this f value is big or small, right? Okay, so then this we have one-way table, two-way table. So for one-way table, for this very simple one-way table, I can ask you to find the chi-square value like this one. Now suppose in our class we have 8 students got A, 12 got B, 11 got C, 9 got D, and totally we have 40 students. But our expectation is 20% got A, 30% got B, 40% got C, and 10% got D. Then we just check whether they are close or not so close. So the test status of the chi-square value is observed value minus expected value square over expected value. Right? Then add them up. We just check each cell. So first cell is just observed value is 8. Expected value is also 8. Like 8 minus 8 over 8. The second number, second number also. This is really really good. Like match second one is also really matches our assumption. Right? Exactly 30. Right? So the 12 minus 12 square over 12 is which is 0. Then 11 minus 16 square over 16. So plus 9 minus 4 square over 4. Yeah, not 9, right? Divided by 4. So for those simple calculation, maybe I will ask you to find those chi-square value, right? So based on chi-square value, make a decision. So suppose I say I wanted to compare 4 classes. So I tell you I find chi-square value thus. So you need to determine p-value less than or larger than 0.005, or make a decision, or you need to find a critical value. Find a critical value to determine this big or small. Right? This big or small. So this critical value from chi-square table, so chi-square table degree of freedom is thus. So Okay, so you check this check a critical value with this degree of freedom, and alpha. If do not specify, then we say alpha. Usually we pick 0.005. Okay. Okay. So if we find this chi-square, this number test statistic or chi-square value like 12.34, if this big, what you can say? This means like observe true data and our assumption is not match or differ very much. So here our assumptions, this class is 4 classes, no difference, right? So data and our assumption not so close, not match very well. So this means then these 4 classes have a difference. Okay. So if this is small, we say not much difference. Okay. So the last one is just the regulation. So for regulation, we have 2 questions. Usually find regulation line, find B, find A. Okay. So again, like I check this example again. Yeah. So you can find, and the significance. So you find F value, so make a decision, right? So find significance. Suppose like I have those data, then find those SSR, SSE is tough. So I will tell you, SSR is this, SSE is this. Then I will ask you find make your decision, right? So to make your decision, you need to compare. You need to find F critical value, then determine this F critical. This F value is big or small, right? Okay. So those are all the materials we covered so far. So we spend a whole semester cover those things, but go back to have a look at. It seems like a very easy, like only very few topics, right? Okay. So anyways, we finished for this. We finished the whole class material for whole classes. So then this next Monday we will have our final exam. Okay. So if you have so we can stop here, and if you have any question, email me. And oh, by the way, I almost forgot. Please take some time, give me my teaching evaluation. Okay, so take some time to do the teaching evaluation. So this your teaching evaluation is just my grade for my teaching. So your course grade is determined by you, but my teaching grade is determined also by you. Okay. So anyway, so thank you for taking my class. I hope I can see. Hope you can get good grades and enjoy your winter break. Enjoy your Christmas break. Okay, and hopefully I can see you around the campus, and hopefully if you have some interest, you can take my class again. Okay, thank you. Bye bye.